So we are going to go over difference of perfect squares and grouping. So these are two separate methods. When we have perfect squares, keyword is difference. So difference means we have minus. So for difference of perfect square, we have to have a perfect square minus a perfect square. So an example would be 81x squared minus 9. 81 is a perfect square, 9 is a perfect square, and we have that minus. So the way we do this is my a value is equal to the square root of 81. So right here, a comes before b, and 81x squared comes before the 9. So we simplify, we're simplifying a radical. A is equal to 9. Then my b value is going to be the square root of 9. This simplifies to a 3. So when we factor, we're going to use our formula of ax minus b times ax plus b. So our answer is going to be 9x minus 3 times 9x plus 3. Let's try another one. So if we had 25x squared minus 4. 25 is a perfect square, 4 is a perfect square, and we do have this minus sign. So we set a is equal to the square root of this first number, which simplifies to 5. And b is equal to the square root of that second number, 4. And that simplifies to 2. So we use our formula. This factors to 5x minus 2 times 5x plus 2. Now on the test, you could see something like this, or for the test, you might see something like x squared minus 16. Remember, we have an invisible 1 right there. That is 1x squared minus 16. 1 is a perfect square. 16 is a perfect square, and we have that minus. So my a is equal to root 1, which simplifies to 1. My b is equal to root 16. That simplifies to 4. So my factored form is ax squared plus b, 1x plus b, so 1x plus 4, and then ax minus b, 1x minus 4. This is perfect squares. It is the difference of perfect squares, so we have to have that minus. And this first number has to be a perfect square, and that second number has to be a perfect square. For grouping, something special about grouping is we have 4 parts. Part 1, Part 2, Part 3, Part 4. So step 1 is we're going to draw a line. And so we have this divided into a left side and right side. Then we're going to do GCF. So if I look at my left side, the GCF is going to be x squared. And in the parentheses, I am left with x minus 3. On the right side, it is important, see that negative 5x, that means we have to take out a negative. It doesn't matter what numbers there are. If you see a negative something x on this right side, you have to take the negative out. Then my GCF is a 5. So inside the parentheses, we have x minus 3. Something you need to check for is x minus 3. Check, they are both the same. So our final answer is going to be x minus 3. And we are left with an x squared minus 5. Over here, draw the line. On our left side, the GCF is x squared. And inside the parentheses, we have 2x minus 5. We get these numbers because x squared, if we draw this, x squared times 2x gives me x cubed. X squared times minus 5 or negative 5 is a negative 5x squared. We see that's a positive, so we take out a plus. A positive, there is nothing in common except for 1. And inside the parentheses, we are left with 2x minus 5. So this final answer is 2x minus 5. And we are left with an x squared plus 1. See how that is a plus? That means we cannot do perfect squares. This does not work. If we had x squared minus 1, then we could do difference of perfect squares. Over here, we draw our line. Left side, our GCF is x squared. So we are left with x minus 7. On our right side, see this plus. That means we have to take out a plus. Then 9x and 63, the GCF is 9. So inside the parentheses, we have x minus 7. Our factored form is x minus 7. And then we have x squared plus 9. Look, that is a plus, so we cannot do difference of perfect squares. If we had x squared minus 9, that is equal to x minus 3 and x plus 3. So remember, the difference of perfect squares, we do have that minus sign.